Okay, as a reminder, your final is everything on the second half of the year. So anything February beyond after the winter break, okay?
That is all the stuff I don't get.
So, first one is going to be system equations, which we had on February 6th to test.
Wow.
Okay, so the first one is a graphing question. Remember, most of your test questions are multiple choice. So for a graphing one, I probably would have it graphed out for you, and you would just tell me where it crisscrosses. But here, we would graph this. So let's talk about graphing a bit. Y equals 3x minus 1. That means our slope, or our m, is 3 over 1, which means I would go up 3, right 1, or the reverse, down 3, left 1. There's also the b value now is negative 1. That means I start my line at negative 1 on the y-axis. So remember, it's going to start on it's a y-intercept, so it starts on the y-axis. So then I go up 3, 1, 2, 3, right 1, and I keep going until I fall off the graph. In this case, I only could do it twice. Up 3, right 1, up 3, right 1. And I make sure to go backwards too. Always make sure to go backwards just in case. And let's connect the dots. Again, we're going to do the next thing. The other line is going to be drawn too. So it's negative x. Remember, that's a visible negative 1 in front. So the slope here is negative 1 over 1, which is down 1, right 1, or the reverse, up 1, left 1. And here the b value is 3. So I'm going to start at positive 3. If I'm going a bit fast, I apologize, but this is recorded, so you can always check it back later.
Oh, you're recording?
Yes. So I'm going to go down 1, right 1, down 1, right 1, up 1, left 1, up 1, left 1. I can keep going, but since this is a system of equations, what I care about is where they crisscross. So my answer is where these two crisscross, which happens to be right here, which is 1 to the right and 2 up. So your answer is 1, 2. That's an XY coordinate.
So like the point where they like connect, that's the answer.
Yeah, where they intersect. What's up?
What if you just like know the answer?
Remember, it's multiple choice, so you don't have to show your work or anything.
What if you get like the first digit and then you know the answer?
That helps too. That's using multiple choice to your advantage.
Wait, what do you mean multiple choice? Like you're gonna give us the
A, B,
graph?
C, D.
Oh, but you're gonna make them like you're gonna give us the graph and then you're gonna write like the number.
Yeah, I mean, there's multiple ways I could write the question, but yeah.
I have like a hard time graphing sometimes. What if it's like in between? He's gonna give us the graph.
I mean, it's multiple choice, so then you look at the multiple choice, maybe eliminate some of them, and then you could guess. Okay. Like you could make an educated guess, I should say.
I'm gonna leave one question free so I can study.
All right. Next one.
So the number that comes before the x is the y?
The number in front of the x is your
Y.
slope. No, the number after.
I don't mind.
The one alone is your y-intercept.
Before is the y intercept.
The 4 in this case is the y-intercept.
2x is basically
Oh my
2 over 1
God.
is the slope, right?
Yes, it's the slope. So for this one, the first one is m is 2 over 1. So up 2, right 1, or down 2, left 1. And then your y-intercept is positive 4. So I'll start at positive 4, and then go up 2, right 1. Can't even fit
Go down to the
left 1. Make sure left 1, okay?
So obviously so you're going right, which is positive, and left is negative.
Yeah. Think of it as English. English is right, is positive. Like you would read left to
The
right.
slope will only
So
matter.
this one is parallel, right?
So if the 2 is negative, then it would be a negative slope, basically.
Yes, it will be down to right 1 in that case. All right, next one is 2 comma 1. So it's up and right or down and left. And your b value is 1. So in this case, this is a special case, we call this.
What's the
parallel. No solution.
This is parallel. So the two lines are parallel. But if I'm asking where they intercept, they don't intercept. So you would see this as an option in your question as no solution. You find this as no solution. All right. Next page. It says solve by substituting. Now on the test, since it's multiple choice, you don't have to. I don't even look at your work. You just answer it how it is. So if you want to use substitution, if not, it doesn't matter. You're not forced to do anything here.
What do you write as your answer for the y equals mx plus b again?
What's up?
What do you write for the y equals mx plus b? Like, when you solve that, right, you get the answer, but what do you write?
For the last question, number 2,
Yeah, like, what do you write though? Like,
it's no solution, but it's multiple choice, so you circle no solution in that case. All right, next one, number 3. So it says solve by substitution. That means what I'm going to do is take what's equal. Since this equals y and this equals y, since they both equal the same thing, aka y, I can set them equal to each other.
so 3x minus 5 equals 2x plus 1.
3x minus 5 equals 2x plus 1.
Doesn't matter if you put.
Doesn't matter which one's first or second. Now, remember, when you have multivariables, I always suggest moving to smaller one. It avoids negatives. So minus 2x minus 2x. So I got x minus 5 equals 1. Plus 5 plus 5, x equals 6. So x equaling 6 is useful, but in your answer, you need x and y. So I'm going to take the 6 and plug it back into one of my originals. Doesn't matter which one you plug in, they both should work. So I'm going to plug it into the top. So 2 times 6 plus 1 equals y. 12 plus 1 equals y. 13 equals y. So your answer here is 6, comma 13. Yeah. Calculator is available the whole test.
Okay.
Keep in mind though, everybody in school is taking a math test at the same time. So if you're someone who borrows the calculator from the front office, there's probably not going to be any because everyone's already borrowing them. So make sure your calculator is fully charged, you have fresh batteries, because there's nobody else with extra calculators. Everyone's using them at the moment, okay? The whole.
Exactly my phone for.
No, you cannot. So next one. So this one equals y. 2x plus 3 equals y, which means I can replace the y with what it equals, which is 2x plus 3.
2y.
So it's going to be 3x plus 2. I'll use red to make the difference. This y is becoming 2x plus 3.
Does it matter?
In this case, I do the bottom one because the top one already by itself. So I could just substitute it to the bottom one. Equals 13. So what I did is I changed the y into the equation that it equals to. Now we're going to have to FOIL. 3x plus 4x plus, remember to distribute correctly, 6 equals 13. Combine some like terms. 7x plus 6 equals 13. Minus 6 on both sides. 7x equals 7. Divide by 7 on both sides. X equals 1. Just remember, we're not looking for just x. We're looking for x and y. So take that, plug it into here.
Is this what the final is going to be like?
So then y equals, so during the y equals.
With multiple choice questions.
Oh, so these are going to be multiple choice?
Yeah, I'll give you multiple choices.
Do we have to show work?
No, I don't even look at the work. I have a Scantron like you use. Like in
Oh
an
my
SAT.
God.
So really,
Oh,
like,
it might not be that hard.
I don't think it's that hard.
I mean, depends.
I would say like this. The per question, let's say pound to pound, is like easier, but it's just harder because you're doing all of it at once. That's where the difficulty is that you're doing the whole half a year.
Wait, why? Where did you put in the parentheses?
1, 5, my fault.
Why is it not 5,1?
What's up?
Why is it not 5,1?
Remember, x always goes first. So it should be 1, 5.
Okay.
Don't be surprised if I put one of your fake answers as 5, 1. That's part of knowing the thing, okay? When I make the multiple choice, I'm always looking for who's going to get caught
We go to like chapter like 10.
when I get there.
Really?
Yeah. What was your question?
You know, if we like skip, is like I get it.
Okay, well, it's not just being a
Shane, try not to make an enemy out of everybody, okay? So, this one, we're going to use elimination. Elimination is really useful when your x's and y's are already lined up. technically you could always rewrite anything to be substitution, or vice versa. You could write a substitution to become elimination. Usually I set them up so that one is better than the other. So in this case, this is good for elimination. Because they're lined up, what I'm going to do is subtract vertically. And I can subtract vertically because they're already lined up. Now, the reason I'm subtracting is because I want to eliminate one of them. So like 3 minus 3 is 0x, which is good for me. I want to get rid of it. So I don't even need to write 0x technically. Then 4 minus 2, 2y, equals 8 minus negative 2. Remember, it's 8 minus negative 2, so that's 8 plus 2, or 10. So 2y equals 10, divided by 2 on both sides. Y equals 5.
Where do you get 10 from?
8 minus negative 2. Now we're going to take this y and plug it into one of the original ones. Doesn't matter which one you plug it into. I'll plug it into the top one. But if you plug it into the bottom one, it's the same thing. 3x plus 4 times 5 equals 8. Remember, it equals y, so you replace the y. 3x plus 20 equals 8. Minus 20. Minus 20. 3x equals negative 12. Divided by 3. Divided by 3. X equals negative 4. Your answer is negative 4, comma 5.
Does it matter which one we choose to subtract?
No, it does not matter. You plug it in either one, they should both work.
So
Assuming you did the work earlier correct, then yeah, it should
why
work.
you solve it if I did 3x plus 2 equals negative 2, like times negative, like by negative? Like it would be like the opposite, because you put opposite here, like you put negative.
It's 8 minus 20, that's why it's negative 12. I don't know what negative you're talking about otherwise.
No, like
Oh, why did I subtract?
yeah, no. When you did that, do I have to add that here to for x?
No, you don't have to add that negative, no.
Okay.
All right, next one. Now, this one I would love to eliminate, but the issue is none of them match. They don't match each other. What I can do is force them to match by multiplying the top and bottom by a number.
But they do
So
match.
you can do 4.
Which one matches?
4 and 3, right?
Oh, you mean like they don't like.
The numbers don't match.
Subtraction?
Usually, yeah.
So I can do 4 on top and 3 on the bottom.
Yeah, I'm going to do 3 on top, 4 on the bottom to make the x's match. But if you did it like that, you will still get the right answer. So don't sweat
I
it.
still.
You divide by.
Because you'll be eliminating the y's
You
in that case. That's
multiply
fine.
by y.
I'm multiplying by the other numbers. So since this is a 3, let's say if I want to make my x's match. Since this number is a 3, I'm going to multiply the top by 3. And since this guy has a 2, I'm going to multiply the bottom by 2.
Okay.
Mr. Tobel?
Yes.
Do you have expectations for the class to get it like a certain grade?
Not really.
No.
What a good question, Shane. We needed that question. I honestly don't know how to do without that question.
We do
18 times 2 is 36. So in this case, we have them. I multiplied it. Don't forget to multiply this number. A lot of people forget to multiply that number. But either way, now the x's match. So I can now subtract down. My x's disappear, so that's perfect for me. That's my goal. So 9 minus 8 is just a single y. And 39 minus 36 is 3. So since y equals 3, I could take that and plug it into one of my original equations.
Isn't it 1 though? For the
No.
9 and the 8.
39 minus 36 is 3. 9 minus 8 is, 1. But because it's a 1, I don't have to write that.
Y is equal to y.
Not y equals 1. There's a 1 in front of the y. The coefficient of y is 1. Yeah, it's a visible one.
Mr. Tobel?
Yes.
Can I add the negative like before you do the multiplication?
You could technically multiply by negative 2, yeah.
Yeah.
And then, but you got to make sure you're adding down, okay? So 2x times 3 equals 13. Notice I'm using the original one. I recommend using the original one to minimize mistakes.
We get y equals 3 from.
Look at the work. 9 equals 13. Minus 9. Minus 9. 2x equals 4. Divided by 2. Divided by 2. X equals 2. So my final answer is 2, comma 3.
That problem takes like it's gonna take you like 10 minutes in itself.
I would another suggestion. This is useful for the final. This is useful for SAT, ACT, whatever test it is. Guys, shh, in the back. If you ever get stuck on a question, since every multiple choice question is equal the same, this doesn't work for normal tests because all the questions are worth technically different. But since every multiple choice question is worth the same on a multiple choice test, always if you get stuck on one, just skip it and maybe go back to it. Okay. And remember, at worst case scenario is multiple choice. So worst case scenario, if you had a guess, you have a 25% gets right. If you could cancel answers, maybe even increase that percent. So remember, as a multiple choice question, you could skip it and come back to it. That is the more effective strategy than being stuck for, let's say, 10 minutes.
Wait, so like, do I get like half credit?
There's no half credits on multiple choice.
If I got it wrong, like,
That's just wrong.
How will you get a half credit if you got it wrong?
I don't know why I said that.
If we show
In your normal tests, I usually give partial credit for your work. I don't look at the work for these tests. So you cannot get partial work. No. Except the open-ended parts.
How about they don't work?
The graphs I do, but because those are open-ended.
Is there like a non?
But the multiple choice ones, I don't look. I just use an app to scan the Scantron. I finish grading all your finals within an hour.
The scam.
Wait, question.
But then I have to do a little bit of math afterwards, so it doesn't go that fast. What's up?
On a bubble sheet?
They're in like there's a separate sheet that you will have to fill in, like bubbles, yeah.
Um,
Like a Scantron. We call those Scantrons because you scan it in a machine. All right.
So for the exported one, like X times
Can
X,
I
what
try to
is
do this?
Minus.
No, I'm just going to keep going. For this one, I'm going to set them equal to each other. When I get there, Dovia, I'm happy to answer that question.
Wait, so we can do it either way. So for 5 and 6, we can do it either way, right?
Yes. You could, on your test, on the final, you could do any way. In this case, I'm going to use substitution. I find this to be the easiest one because they already equal y. You could technically also graph in this case. But again, which one's easier to you is all different. There's every person will have a different answer, so it doesn't matter which way you do it. So I moved the smallest x. What's smaller, 2 or negative 2? Negative 2, so plus 2 on both sides. So I get 4x plus 3 equals negative 5. Subtract 3 on both sides. Don't slip up on your negatives. That's a common error with every grade, but also our grade.
Therefore, x equals negative 8, right?
Good, negative 8. Divided by 4 on both sides. X equals negative 2. I'm going to take that negative 2 and plug it into this equations. So y equals, I'll plug it in the top one, 2 times negative 2 plus 3. Y equals negative 4 plus 3. Y equals negative 1. So your answer would be negative 2, comma, negative 1. No, and when we did this test, I let you choose any method. So graphing could have been the way you done it. That's the only reason why there's a graph there. You're not forced to use the graph.
So if we do number like 1,
So number 8, over here, I tend to find substitution easier, so I'm going to plug in substitution here. So I'm going to plug in the y for this y. So 3x minus 1 equals negative 6x plus 12. You could do it like that. That would be elimination. That's fine. So 9x minus 3 equals negative 6x plus 12. I move the smaller x. Which is smaller, 9 or negative 6? Negative 6. So I'm going to do plus 6 on both sides. 15x minus 3 equals 12. Plus 3 on both sides. 15x equals 15. Divided by 15 on both sides. X equals 1.
So what happens if I did divide by 3 on like every single number?
On the bottom,
Yeah, like.
then you subtract down.
So then.
So it should be 0 equals x.
So yeah.
minus something.
Both sides, yeah. Y
And then-
equals- so this y equals that.
Do you have to?
Well, you have to move it over to the other side, but yeah.
You have to use the graph.
Oh yeah.
No, you're not forced to use a graph. On the test, you had the choice, and on the final, you have your choice too. So that's one, and then it's going to be plug in 1 into the top one. Y equals 3 times 1 minus 1. 3 minus 1. Y equals 2. So it's 1 comma 2. Next page is the next test we took in February 23rd, 2023. A lot of 2s and 3s here. So this one was the exponential rules.
That's a good one.
So this one, the rules, they were new rules, but they're kind of simple. For example, when you multiply two exponents with the same base, 8x and x,
7.
you could add the exponents. So for number 1, that's x7.
This is when I kind of go along.
This one, remember, if you don't see an exponent, it's a divisible 1. So 5 plus 7 plus 1. Some people forgot the 1 in the past. 6 plus 7, 13. X to the 13, I should say. Not just 13, x to the 13. So if multiplication is addition,
7.
division is going to be subtraction.
Oh, sorry. Hey, y7, right?
So it's going to be y to the 7th power because it's 10 minus 3. Go. Yeah. When you have an exponent to an exponent, maybe it looks a little bit more clean like this. When you have an exponent and exponent, you multiply the exponents. So a to the 4th to the 5th power is a to the 20th power. For this one, some people got confused here, but g to the 3rd over 1 times 1 over g to the 2nd. Notice I just changed the first one into a fraction. After I do that, I could just multiply sideways, because when you multiply fractions, you multiply sideways. G to the 3rd over g to the 2nd, which when it looks like this, is obvious to everyone. You subtract. So 3 minus 2, g to the 1st. On the multiple choice, it would just look like g.
Do you just do that exponent times the numerator?
This one? This one? No, I just
But
did.
you did the G3 times 1.
It would just be G3 because times 1 is the same thing, right? All right. This one, normal numbers multiply normally. So 3 times 6, which are normal numbers, it's just 18, not 9. I remember some people wrote 9. While exponents follow the exponent of it. So it's going to be x to the 5th. So that one,
Wait,
you add the exponents. This question was designed to show you the difference between normal numbers and exponent numbers. This one is to show you that there's technically 2 ways to do it. I'll show you both. Way number 1 is I could subtract first. x6, x2, that'd be x to the 4th to the 3rd power. And then rise the power. 4 times 3 is 12. That's one way to do it. The second way I could do it is first distribute the 3 to everybody. X to the 18 over x to the 6. Then subtract x to the 12. Both methods are valid. That was the purpose of that question, to show you that.
Get 12. Wait, did you get 12?
I did it in 2 ways, so you better figure out how to get 12.
5 times 4 is not 12.
I agree. So, anything to the 0 power
You go back.
is instantly 1.
You go back for a second.
So no matter what I put in here, I could put the craziest thing in here. If it's to the 0 power, it's automatically the number 1. Some people might get confused. You think it's x to the 1. No, it's just the number 1.
Wait, how do you have 1?
Because it's a 0 power. Anything to the 0 power becomes 1.
So wasn't it 2x 1?
2x?
It's on this written down.
Because why is it just what about the 2 and the 3?
Anything. Normal number, exponent, fraction, power, square root, doesn't matter, will become 1. All right, x to the negative third. When I have a negative exponent, I move it to the bottom to make it happy. So it's 1 over x to the third.
Oh, do you keep going to negative? Because it's there?
Yes, because it moves, it becomes positive. So it's 1 over x3. If it was just x3, it's not a question. Then it's just that's just x3.
It's just nothing.
Yeah, there's nothing. There's not a question in that.
So 3 times 0 is just 1.
3 times 0 is just 0.
But no, like,
3 x to the third to the 0 power would be 1.
x to the third power times 0.
Times 0 or to the power of 0?
Times 0. No, like, for number 8.
It's anything to the 0 power is 1. No matter what you put in the parentheses. Okay.
Wait, hold up. How much if we just 1?
What?
If we just 1, it'd be just 2 x cubed, right?
If I put a 0 power, it still stays 1. It's just 1. Now, y to the negative 6, I'm going to rewrite that as 1 over y to the 6. And y to the 4th, I'm going to rewrite it as y to the 4th over 1. The reason I do that, guys in the back, shh. Yafa, Yafa. So then this one is y to the 4th over y to the 6, just like the previous question. Y to the 4th over y to the 6. 4 minus 6 is technically negative 2. Another way you could think of it, there's 2 left over on the bottom. So either write it like that, or write it as y equals negative 2, then move it to the bottom. But the multiple choice answer would be, in this question, guys in the back, shh, I'm not talking over you. It's 1 over y 2. Yeah.
It'll be negative, so you put it under.
Yes. But I could technically do that in one move. I don't necessarily have to show the negative.
Why did you just write
4 minus 6
I thought
is
-2, not just
y negative 2, which then becomes this.
How does it become positive 2?
Because when you move it to the bottom, it becomes positive. All right, number 11. You could think of it as 2 ways. You could think of it as 10 minus negative 4. 10 minus negative 4 is 10 plus 4, or x to the 14th. You could also think of it as x to the 10 and flip this up, x to the 4. So you move it to the top,
Thanks, Mr. Chokes.
which will be x to the 14th. We'll continue tomorrow.